Hello once again, this is Jeff Scott of Rankin Technical College, and I've been going over the online PDF AppInventor2 Create Your Own Android Apps by Wolber, Abelson, Spertus, and Looney. We're up to chapter 22 of 24, and this chapter is on working with databases, as you can see. And what they mentioned at the beginning here is basically most programming environments that are going to have any kind of interaction, if you want to save things and you want to save them so that once you get out of the app or whatever it is you're working on, you've got a permanent copy of it, so you want it to persist, you'll typically use a database. As they mention here, when it comes to databases, App Inventor does the heavy lifting for you. The language provides components that reduce database communication to simple store and get operations. All right, again, to store data persistently, you must store it in a database. You can use files too, but they're much more limited than saving to a database. It says, as an example, remember when we went back into chapter 4 on that no texting while driving app, which sends an auto response to incoming SMS messages, text messages. The app has a default response that is sent, but it lets the user enter a custom message if they want, okay? And that custom message, if you want it to persist, so if you change your message, you want it to stay there, even after the app is closed, you must save it permanently. And a database is one way of doing that. Now, remember, they talk TinyDB and they talk TinyWebDB in here. And you should by now understand and appreciate the difference between the two. When you're talking about TinyDB, that's saving stuff to the machine that you're currently on, the Android device that you're currently on. With TinyWebDB, it basically stores the information in a database that I believe at least is out in the cloud someplace, so it can be used by multiple people. So if I was going to build a very simple game and I was the only one who was ever going to use it, I'd probably use TinyDB. On the other hand, if I was going to build, let's say, my own copy of Flappy Birds, and I wanted to be able to have other people play against me, and we wanted to save scores and the like, then we'd use TinyWebDB. The components, as they mentioned in here, are similar, all right, but TinyDB is simpler. So it says we'll explore it first. With TinyDB, you don't need to set up the database at all. All the data is stored in a database directly on the device and associated with the app. To transfer data to long-term memory, you use tinydb.storeValue. When you do this, you give it a tag, which for lack of better words is kind of like a field name, and a value to store, which is the value, as it says, that you want to store. As it says, the tag parameter gives the data you're storing a name. Again, I called it a field name. It says you can think of the tag as the key that you'll use later when you want to retrieve the data from the database. Likewise, you can think of App Inventor TinyDB database as a table of tag value pairs. After the store value is executed, the database will have values such as these. Now, depending on the complexity of your program, the app might store many tag value pairs, or it might only store one. All right, depending on what it is you're trying to do and how you're trying to do it. The tag is always text, whereas the value to be stored might be a single piece of information, it might be a list, it might be anything in between. As far as retrieving data from TinyDB, as it says, you retrieve database data using the tinydb.getValue block. When you call it, you request particular data by providing the tag. Often you'll retrieve data from a database when the app opens, so that means that you would put the associated call to tinydb.getValue inside of your screen.initialize, which, as we've seen before, is a good place to put things when you want them initialized at startup. All right, as far as sharing data in TinyWebDB, as mentioned here, The TinyDB component stores data in a database located directly on the Android device, which is appropriate for things that you don't want to share. On the other hand, things that you do want to share, and they give examples like Facebook, Twitter, and games, as I mentioned before. The database must reside on the web, not on the device, so that different users can communicate with it, access its information, etc. So TinyWebDB is the web counterpart to TinyDB. With it, you write apps that store data on the web. You still use the store value, get value type of protocol. By default, the TinyWebDB stores data by using a web database that's set up out here. That website, and there may be a 2 after this, I don't know. Let's see if we click here, do we get to anything? Okay. It says, notice the service is being modified, it may go offline. I just, for the heck of it, want to try putting a 2 there and see if that does anything. Yeah, it made it not work. Okay. Or a 2 here, but probably that isn't it either. Nope. It says this service is being modified, so I guess that right now it's probably not something you'd want to be using on a regular basis. And I guess I shouldn't have done that, but that's okay. I went too far. All right, that's a little too big, huh? All right. Again, TinyWebDB is the counterpart to TinyDB. Okay. This website, when it's up and running, contains a database and serves a response to web requests for storing and retrieving data. It also provides a human-readable web interface that a database administrator, you or someone else, can use to examine the data that's stored there. Notice, this default database is for development only. It's limited in size and is accessible to all AppInventor programmers, so other people could overwrite your data or even remove your data. If you're just exploring AppInventor, the default web database is fine, but as it says, at some point you'll need to set up your own web database. In this section, we'll build a voting app as depicted down below to illustrate how TinyWebDB works. The app will have the following features. Users will be prompted to enter their email address each time the app loads. Users can submit a vote at any time. They can view the votes from everyone in the group. It says the issue being voted on is determined outside of the app, so we don't really care what it is. In this case, there you go, what to eat. The TinyWebDB.store value block, as it says, works very similarly to the TinyDB.store value, except again, the data is stored on the web rather than on the individual machine. But you see it looks very similar as far as how it works. In other words, it's got the tag value type of property. Now, retrieving data with TinyWebDB is more complicated than with TinyDB. With TinyDB, the get value operation immediately returns the value because you're communicating directly with the Android device. With TinyWebDB, the app is requesting the data over the web, which might take time, so Android requires a 2-step scheme for handling it. As it says, with TinyWebDB, a call to get value only requests the data. All right? As it says here, and they kind of are showing the difference between these. Notice that the one, all right, it says the TinyDB.getValue returns a value right away, but the TinyWebDB does not return a value immediately, so there's no plug, as it says, to the left-hand side of it here, like there is here. Rather, when the web database fulfills its request and the data arrives back at the device, then a got value. So notice it's get value. Once it gets there, a got value is triggered. So if you call tinywebdb.getValue in one place in your app, you'll have to program the tinywebdb.getValue event handler to specify what you want to do with the data when it actually arrives. And they give you an example. There's the get value, and there's the got value. So they're done very similarly. It's just more complex with the TinyWebDB because, again, with the TinyDB, you're grabbing the information right from the Android device that you're working on and using it. With the TinyWebDB, you're grabbing the information from a database which is out on the cloud someplace, and it says, okay, now you've got it. Now you're able to go and work with it after you get it. So it's a two-step operation. All right, it says the blocks in figure 22-7 are a good model for retrieving data in a fairly simplistic app. In our voting example, however, we need more complicated logic. So the app should prompt the user to type in an email address when the app starts. So you should know this, that we probably will put a notifier inside of screen1.initialize. All right. Only after determining the user's email should you call getValue. And it says, can you figure out why? Well, by giving the email address, then what you're able to do is that becomes your tag. All right, so that if somebody would post something inappropriate or you need to know who posted what, you would have an idea then. Now, there would have to be more complex logic in here because if I wanted to get someone in trouble, I might just, and I know their email address, I might just key in their email address. So there might be more work in this case that I had to do. So again, the author is making this fairly simplistic, and there may be more work that you would want to or need to do. So it says here in our voting app, when the list arrives from the web, got value is triggered. Here's what should happen. Got value should check if the data that arrives is non-empty. In other words, did somebody actually enter something? If there is data, it should check to make sure that, to check if the email address is already in the list. If it's not, it should add that email to the list. Remember, one thing they said in here is whatever this voter app is, you can vote as many times as you want. If there isn't a voter list in the database, then one should be created. And as you can see, when you start going through this, it gets more and more complex. So the blocks, as mentioned here on the top of the page, first ask if a non-empty voter list came back from the database by calling isAList. If so, the data is put into the variable data list. You also have to go in there and check then, do we have the email address already? And if we don't, well, then we have to add that. The else of the if-else block is invoke if a list wasn't returned from the database. In that case, no one has used the app yet, so we have to create a new voter list. The voting app thus far, as it says, manages a list of app users. Each person can see the email addresses of other users, but we haven't created blocks for retrieving and displaying each user's vote. So that's what they're doing next. When the user clicks on the View Votes button, the app should retrieve all votes from the database and display them. That's what we've seen. All right, so when you view them, what do we want to do? Well, we're creating an empty list, and then we're iterating our way through that list and having it go out to the database and get the information that we need. Once we get that information, then we have to display it. And if you look in here, that may very well be the most complex procedure that's in the book. This might be another time where you might want to go and take, for example, you might want to take this if stuff that's in here, put it in its own procedure, even if it's only going to be called once. Do the same with the else that's in here and with the else that's here. All right? Just for readability purposes. All right, as mentioned earlier in the chapter, the default web database is intended for prototyping and testing uses only. You can create your own web database by using the instructions here. Let's see if that goes to anything. Yes, it does. Create a web database. Now you'll notice that it works with Python. All right, and this is a little bit old because it says Python 2.7 or it is 2.7, whereas Python 3, like 3.3 or something like that, is I think the one that's up right now. So as it says, that site that I just clicked on was set up by one of the authors and contains sample code and instructions for setting up App Inventor web database and APIs. So it's a good starting point. In this chapter, we went over some of the stuff regarding databases and persistent data in App Inventor. In particular, we talked about the differences between TinyDB, which stores persistent data on the actual Android device and has just got a get data type of routine, as opposed to, or get value I should say, as opposed to TinyWebDB, which stores it on the web, and it's a two-step process with a get value and a got value. All right, that's it for this chapter. When we come back, as we're working our way through here, next we'll go through chapter 23, which is on sensors, and I'll be back with that lecture shortly.